Hello, my name is David Colson, and this is my breakdown for EMI charts for Clover Park Technical College. In Mechatronics, we practice three main disciplines. The first is mechanical engineering, computer science, and electrical engineering. We can take these three practices and build complex systems. In addition, we can take a complex system and break it down into its components to fully understand it, which is what we're trying to do with this lab. Let's take a look at a complex system. This is a great example of a simple mechatronics platform. This is a small robotics arm that picks up an object from a station, moves to another station, and sets it back down. It has mechanical components that you can see here, including the arm, claw, and also the pneumatic cylinders that power all the movements. It also has a programmable logic controller that uses code to dictate what happens and when. And lastly, it's all powered electrically. Sensors and logic controller all require electrical understanding in order to break it down. So let's use these three components to break it down. So the first thing you need to know about an EMI chart is that it isn't one specific chart. You can make as many charts as you need to fully understand the system. So this is a super oversimplified view of the system to give us a general overview of what's going on. We have electricity coming in from a wall outlet to the computer. The computer actually directly powers the solenoids, which control the airflow from a compressor. The compressor activates pneumatic cylinders to perform mechanical operations, and those operations trigger sensors so that the PLC knows where the robot is in the process. Now, we're still controlling the robot through user input. When we press those buttons and flip the switches, those are activating sensors that are connected to the PLC. This is a quick back of the napkin chart to show anybody who doesn't know what this system looks like or how it functions, what it actually does physically. It shows all three of the different outputs the system has in order to manipulate the objects, and it explains what they do really simply. So this one is a high context chart for the system. This is actually the first chart I made, and this breaks down what connections go where and what triggers what. This is something we could use to basically rebuild the system from the ground up, and it would also show us if something's failing, where we can go to troubleshoot it. So you can see from left to right, we have the PLC outputs connected to the solenoids, which is the only thing we can actually control in the system. These solenoids get air in from the compressor, and then it can lift, rotate, and activate the claw. Our user inputs are down here. The labels for all of our sensors on this portion of the chart, the labels for our inputs as a user, and the inputs those are connected to on the PLC. So this chart helps us understand logically what's going on, what the PLC is able to see and interact with. This is the last chart I've made for the system. It breaks down how our electrical connections are made inside the system. It shows where shore power comes in, how it's converted within the system, and then what voltage is put out to which components. It makes a lot of sense to separate our electrical out from our information slide because it makes a great distinction from what is power and what is information or control. So this is how I've broken down the system. Ultimately, it's just making what charts I need to help somebody else or myself understand the system as well as possible. And following EMI is the best way for us to logically break it down. Anyway, thanks for watching.